Okay, welcome back again. And I hope you guys are hearing me loud and clear. Okay, so we have a situation here and whereby we are asked to take the square root of a negative number. And if you use your calculator, are you guys hearing me? Let me confirm that first, please.
Yes.
Okay, great.
Yeah. Okay.
All right. So now, once you solve quadratic equation, you come to a point whereby the terms that are within the square root, it becomes negative. You cannot go further than here because we cannot find the square root of a negative number. It's impossible. That's why you have a math error when if you want to perform the square root of a negative number with your calculator, you will have a math error with your calculator. So here is where you will stop. Of course, there are methods whereby some higher mathematics can deal with this, but that is beyond this class. So what we can do, we can just conclude that the quadratic equation, it doesn't have a root. So, or it doesn't have a solution. You understand? Root or solution. It doesn't have a solution or a root. It doesn't have a solution. So this is where you should stop. So this, it is important. So what this is telling us that we have this x equals to, if you look at the quadratic formula very well, we have b raised to the power of 2 minus in 4ac. We have this all over 2a. So if you look at this term within the square root, it is very, very important, and there is a specific name for it. I don't know, those who have seen higher mathematics in somewhere, can someone help us? What's the name of it? This b square minus 4ac. There is a name for it in mathematics, and it helps you to determine whether quadratic equation has one solution, two solution, or no solution. What is the name? How do we call this b square, the terms, the mathematical expression within the square root? How do we call it in mathematics? The discriminant. Have you ever heard the word the discriminant?
No.
Okay, so so we call this as a discriminant. So this term here, it helps you to, even before you start solving quadratic equation, you can even somehow know it, whether it has one solution. So remember when we said one solution, we will have x1 equals to x2. They will all give you the same answer. So two solutions mean that x1 answer and x2 answer, they will be different. So the third one is when you don't have any solution. And that is when the discriminant here, or the term with inside this square root, it becomes negative. Then there is no answer, there is no solution. So here you have two solutions in this case. Here, here you have one solution. Here you have two solutions. That x1 will be different from x2. And the third case is this one, whereby the expression within the square root becomes negative. So first, this discriminant is an important mathematical expression. It helps us to determine whether there is a solution to quadratic equation or not. So let's look at it very closely. So we have b square minus 4ac. So this is what our discriminant. So how do we know that there is a solution, there is no solution? And if there is a solution, is it one solution or two solutions? So first, when b square minus 4, when you calculate this, having a specific quadratic equation, if it's greater than, if it's greater than 0, then we have what? Two solutions. Then we'll have two solutions. meaning that we will have x1 and x2. That is, x1 will be totally different from x2. So there will be a solution, and the solution will be 2 solution. So second, when we calculate this expression, that is b square minus 4ac, if it's equals to 0, remember the first example we did, in the square root we have a 0 there. So then we will have one solution, meaning that x1 and x2 will be the same. The third one, that is when b square, when we minus it from 4a square and it's less than 0. Less than 0 means it becomes negative. So greater than 0 means that the number becomes positive. Then we will have what? No solution. So you will see that the discriminant can help you to know whether the quadratic equation will have solution or not. So once you do here, this is minus 47, we know that it's less than 0. So there's no solution. But if the number here is greater than 0, meaning that it's a positive number, then there will be a solution, and the solution will be 2 if it's greater than 0. But if you calculate this expression here and it's equals to 0, then we will have solution, but the solution will be what? One solution only. So is there any question relating to this before we move on to another, to graphing quadratic equations? If you have any question, you can ask. Okay, so now we know how to solve quadratic equations. The next step is to see how we can graph quadratic equations.
So,
Yes.
may I see a view of the first equation you solved? Just the equation. I just want to note it down.
Which equation?
The first one that you solved. This you say factorization. I don't know whether.
I cannot go back to, this is a video. That one is gone.
Oh, okay. No, I'm not saying like the procedures, just the equation itself.
Were you not writing, mister?
No, I didn't wake up earlier. That's the problem.
We should be writing. We cannot totally depend on this article, the video. This was the equation, the first one, where I use factorization. We have to write simultaneously. We should see this as a physical class. Sometimes the audios, they can be horrible, and sometimes to convert them also, the quality is not there. And sometimes also people talk and it might also reduce the quality of the video. But once you take the notes, then you have the video, the audio, I think it helps. So this was the equation, the first one we solved. All right. So now we have seen how we can solve a quadratic equation. We can use quadratic formula or factorization. Sorry. Someone was asking, Hello. Okay, so let's move on. How to call it? We have learned how to solve quadratic equation. We know when there is a solution, we can use the discriminant to determine whether there is a solution or not. And if there is also a solution through discriminant, we should also be able to know whether there is a one solution or two solution. So when it comes to solving quadratic equation, there could be solution, there could be no solution. And if there is a solution also, the solution could be one or two. We know all this. This is the takeaway from what we have done so far. So now how do we graph quadratic equation? How do we graph? How do we graph? Or we sketch? How do we graph or sketch quadratic equation? So remember, the goal is to know how to solve them and how do we sketch them. So when we understand the mathematics of solving quadratic equation and sketching them, then we will apply it in real life, like demand. We will apply it to a demand equilibrium in the market, but the demand and supply curve there will be non-linear, that is quadratic. They will also go on to solve total revenue and total cost, then total profit function, something like that. So here, first, we need to understand the approach here always is to learn the mathematics of a topic, then go on and apply it in business or in economics. Okay, so now we have this. There are 3 steps that you have to normally take when you want to solve quadratic. Let's assume that we have a quadratic equation like this in the standard format. This is 2 plus bx plus c then equals to 0. And they ask you to graph this. So you can, they ask you to graph. This is a general form. We will look at a specific example whereby A, B, and C are replaced by numbers. But before we go to a specific example, it's always good to look at a general form of any topic you are dealing with or equation. So first step, when you are asked, step 1, to graph a quadratic equation, step 1, you should ask yourself, remember, quadratic equations normally are like this, or they are like this, So this is a U shape, this one is an inverted U shape. So if you look at a quadratic equation, you understand, you should be able to know, just looking at it without not even starting solving it, you should be able to know that whether the shape will be like this or like this. And how do you know that? So first step is you have to determine the basic shape. So you have to determine the basic shape. You can know this just by looking at the quadratic equation. So what we mean by, or what I mean by determining the basic shape is you have to know whether it's like this or it's like this. And if you looked at this, we have this coefficient here, we have this here, this here. This coefficient A, that is the coefficient attached to quadratic term, this one, the sign of it will help you to determine whether we will have a U shape or inverted shape. By U shape, this is what I mean by U shape, and this is inverted U shape. So the coefficient here, the sign of this coefficient will determine whether it will be U shape or inverted U shape. So when this A, that is this one, if it's greater than 0, and what do we mean by greater than 0? If it's positive, let's say it's 2 or 3 or 6. If it's positive, then this curve, the basic shape will be what? It will be U shape. It will shape like this, the graph. It will shape like this if it's greater than 0. But in a case whereby the A, the coefficient of the quadratic term, if it's less than 0, the shape of this graph will be what? Inverted U shape. So points here, which is the highest point, and here, which is the lowest point, these are very, very important points that normally in quadratic you have to find it. So here we call it the maximum point of the graph. And here we call it what? The minimum point. The minimum point. So when you are dealing with quadratics, you will have a U shape. The U shape could be like normal U shape, or it could be inverted. And what determines the shape of this graph? It's the sign of A, that is the coefficients of the quadratic term, as it is just explained here. So once you determine this, now you have this visualization in your head. I will have a U shape or inverted U shape. You go to the second step. So in the second step, you determine what? The y, or any variable that is on the horizontal, on the vertical axis, y-intercept. So how do you determine the y-intercept? Remember, we have this. This is normally y. The variable can change. It can be quantity or something like that. But what is important is to determine the vertical intercept. So how do we find, and when we say vertical intercept, we want to know where this, like let's say that this is this. So we want to know this, where it cuts the y-axis or the vertical axis. You can easily also, you don't need to calculate anything. By looking at the quadratic equation, you can easily find your y or vertical intercept. So your vertical intercept, that is where the graph cuts the vertical axis, it will always be, you don't need to calculate anything, it will always be the value of this. It will be C. So that is step 3. You have to know your vertical intercept. That is where the graph cuts the vertical, or if it's y-axis. If the variable here is y, it could be anything. But the constant there is that it's a vertical axis. We want to know where the graph cuts the vertical axis. And for quadratic equations, it's always this C. So you have seen that we haven't even solved anything yet, but we were able to determine the shape. By looking at this, it can tell us what kind of, by looking at A, we can tell what basic shape we will have. And by looking at equation, we can also know the vertical intercept as well, or the y-intercept in this case. So step 3, where you have to do some work, it is step 3 where you have to do some work. So in step 3, you have to determine so let's just this cuts here, in fact, to make it that there's a solution. So determine the x-intercept. So to determine the x-intercept is the same as solving the quadratic equation. They want you to find the value of x1 and x2. So because at the end of the day, you understand, so this x, maybe there is another, it could be quantity. So that's why some people will say the horizontal intercept. So we want to know the point at which the graph cuts the horizontal intercept. And this is our horizontal intercept, but mostly represented by x. For example, we can have a graph like this. So this is what we mean by x-intercept or horizontal intercept. We have to find this. So finding this meaning that solving the quadratic equation using what? Quadratic formula. So we use our quadratic formula, if you remember this formula, to find the value of x, or x is this, which now I'm sure everyone can do now, over times 2a. So these are the 3 steps that you need to do. Determine the basic shape. How do you know the basic shape? You look at the sign of A. Then you have a visualization, whether it will be maximum, minimum, or maximum U shape. Then you come here, you determine the y-intercept or the vertical intercept. And the vertical intercept, you don't need to calculate, it's always this one. So here is where the work lies, which we have done already. We know how to calculate the x values. So if you don't have any question, then we can take a typical, we can take a specific example or a numerical example to draw a graph of a quadratic equation. If you have a question, you can ask. Okay, so anytime you are confronted with a question of drawing quadratic equation, always take these 3 steps. I have some notes. I will share it with you as well. on these steps of quadratic equations. Okay, so now let's take one practical example. For example, this example, let's look at this example. And the example is taxed in, or said sketched or draw the graph of the equation below. So it's asking us to draw it. And what's the equation? It says minus x raised to the power of 2 plus 8, let's see, 8x minus 12 equals to 0. So this is the quadratic equation given to us. And now they ask us to draw it. So now write this somewhere because you will need it, the equation, because I'm going to the next slide. So when you are asked to draw a graph of a quadratic equation, we mention of 3 steps. So let's go through those 3 steps. So step 1, by looking, you have to determine the shape of the graph. So just by looking at the equation, which is minus x raised to the power of 2 plus 8x minus 12. So here, if you looked at this, we know that our a is the coefficient attached to the quadratic term of the equation. And we know that this is our quadratic term. And we have minus here, and obviously there is a 1 here. So a must be equals to minus 1. And our b is what? Our b is positive 8 or 8, just 8. And our c is what? Minus 12. So to know the shape of this quadratic equation, you looked at this one. We have to look at a, the sign of a, and the sign of a here is what? Is negative. And we said that if the sign is negative, what did we say about the shape? If it's less than 0. So we are seeing here,
1 point.
So a here is equals to minus 1, which is less than 0. In another word, a is less than 0. So obviously the graph will look like this. It will be inverted U, not so.
Yeah.
So you visualize this already. I'm taking a lot of time to explain because I want people to understand. But by just looking at it here, you know that this is minus 1. You know that whatever I will draw, it should look like this. If it doesn't look like inverted U shape, then there's a problem. So this will guide you that, okay, this is how your graph should look like. So you go to step 2. So what does the step 2 tell us? We have to find the vertical or y-intercept. Find the vertical intercept. So the vertical there could be y or y-intercept. And we always said that when you have a quadratic equation like this, plus 8x minus 12, then we have equals to 0. Then we know that a is what? Minus 1, b is 8, and C is minus 12. And we said that our intercept is always what? The C. So the intercept is minus 12, the vertical intercept. Now we know that this should look like this. And we know that the y-intercept, the graph should cut at here, minus 12. So if you forget about this one. But here at minus 12, the graph will cut this y-intercept. We know that. So we know that here it will cut it like this for some reason. So we might be thinking that, okay, this might be like this. But what is important here is just to know the minus 12. So first we know that it will be look like this, and it will cut y here on here. The third one, which is the most important, because it's where you will put some work, is to find the roots of the equation, or the solution to the equation. So we can use our formula, which is minus b plus or minus b raised to the power of 2 minus 4 AC over 2 times A. So we know that our A is what? Minus 1, remember. B was what? Minus 8, not so 8. What was our B is 8. And C is our minus 12. So now we have to substitute these values into this. So if we do that, we will have something like this. X equals to minus 8, because B is 8, plus or minus in square root. What is a B? B is 8 minus 4 times A. A is what? Minus 1 times what? C. And C is what? Minus 12. All over 2 times minus 1. So now our X will be minus 8 plus or minus . So when we do this, we will have 64. 8 times 8 is 64. Then we will have 12 times 4. That will give 4 times minus 1. 4 times minus 1, that's minus 4. Minus 4 times minus 12, that will give us 48. Plus 48. We have 48. So all over minus 2. And this will give us minus 8 plus or minus. So 64 minus 48, that will give us 16. So we have here 16 over minus 2. So we go to the next slide. Then we will have what? X equals to minus 8 plus or minus, we have 16 here, over minus 2. So this will give us what? Minus 8 plus or minus 4. The square root of 16 is 4, all over minus 2. So what we can do that, we can break it. X1 will be minus 8 plus 4. We take the first one plus, all over 2 minus 2. Or X2 equals to minus 8 minus 4 all over minus 2. So obviously this X1 will give us, this would be, how to call it, it will give us minus 4 divided by minus 2. And this will give us 2. And x2 will give us minus 12 over minus 2, not so. And this will give us 6. So at the end of the day, x1 equals to 2, x1 equals to 2, and x2 equals to 6. So this is what we need, and it's the solution of the equation, or the roots of the equation. So you will see that here, the discriminant here is positive, is 16. So we say that if it's positive, then we will have two different, we have two solutions, that is x1 and x2 will be different, like 2 and 6. So it's important what kind of, because this 16 is mean positive, is greater than 0. So if the discriminant is greater than 0, then we will have two distinct roots. In another word, we will have two solutions. In another word, x1 will be different from x2. But here, when it's negative, there will be no solution. But when it's 0 here, then there will be only one solution. That is, x1 will be equals to x2. So these are what we need for now. Step 1, step 2, step 3. So we have this information. Let's see how we can use this to graph. Let's see how do. But another important point that it's not telling you that we should find the average of 2 and 6. So what I mean by that, we know that now the first root is 2, and the second root, or the solution is 6. So we want to find the quantity, or the value of x that maximize the function. Remember, we said the function will look like this. So when we have x here, like x, now we have this. So we want to know this value for y, and we want to know at what value for x. So to know this point here, remember this looks like maybe this is 2, this is 6. But if we want to know the point, the x value that maximizes this function here, all what we need to do, we have to find the average of x1 and x2. So x max here, that is the value of x that maximizes the function. To find it, it will be 2 plus 6 divided by 2. That's the average. So at the end of the day, this will be 8 divided by 2 equals to 4. Or in fact, it will make more sense drawing the graph, then you will see what I mean by this. Or for now, what is important, know that to find this 4, what we did is to find the average of the two roots. So 2 plus 6 divided by this 2 is always constant. It will always be there. So what you need to do is 2 plus this 6 divided by 2. So once you do that, this value you are having, you will see that it's very, very important, because it's the point at x here that maximizes the value of this function or equation. So what we need to do also, once you have this 4, we substitute it back in the equation. But before we do that, let's graph and see. Let's graph and see. So what we can do is we can choose the units. We can still do 1, 2, 3, 4, 5, 6, 7. Likewise here it goes 1, 2, and it goes. So for y-axis, we will use 2, 2. We will use 2, 2. So this will be 2, this will be 4, this will be 6. You can use your units, no one is restricted, but you use a unit that will make your work easier. Okay, So remember the first step, we said that the graph should look like this. And that's the first step. The second step, we said that the graph should cut y-axis or the vertical axis at where? -12. And we also know that we find the roots where x1 is equals to what? I think it's 2, yeah. And x2 is equals to 6. So this is what we need here. So first, let's locate these places. Let's have, this is 2, this is 4, this is 6, and let's say it goes until -12 here. So we know that this point is important because it's the intercept, not so, where it cuts the vertical axis, remember? So we also know that there is another point, x2, like here, this is important.
Sanale. Sanale. Sanalang karambat.
The one saying Sana, you are disturbing the class. Okay, so we have x1 equals to 2 and x2 equals to 6. So we have these points. So we know that these two here, this is our x1, by the way, and this is our x2. And this -12 is what? Our y or vertical intercept. So we know that the graph should look like something like this. But we want to know the maximum point here, and also where here, the x. So to find the value that maximizes the function, you take this 2 plus 6, as I did here before, to find this 4. So this 2 plus 6, that is the root, you divide it by 2, it will give you 4. So this 4 is the point where the function is maximized. But we will take this 4 and evaluate, use the function, where is it? Where is the, so take 4, this. Don't worry, I will tell you how we got this 4. But this 4 is clear. How we did it is we take these roots, 2 plus 6, which will give 8, and divided by 2. So at the end of the day, we will have a function like this. And this one will cut here. So this is a point where the function is maximized. Sorry, my graph. So here, x equals